So our last major topic is called many-to-many relationships. And up till now, everything that we've done is what's called a one-to-many relationship. And that is, there are many tracks associated with one album. There are many albums associated with one artist. There are many tracks associated with one genre. And you can think of labeling, and as you look at data models, they put little labels on each arrow that tell you which end of the arrow is the many and which end of the arrow is the one. And so in this case, the foreign key is pointing to, there are many of these rows over here, many rows that point to one row over here. So it's a many-to-one relationship. There are various ways. Sometimes I'll put two arrows at this end and one arrow at that end. But whatever it is, this kind of thing we've been showing is a many-to-one relationship. And that's probably the most common thing. But there are times when you just can't model things with a one-to-many relationship. So like if you have a mother and children, well, that's a many-to-one relationship, and it's just fine, and that works fine. But sometimes you have a many-to-many relationship in that there might be many books. One book has many authors, and each author has many books. And so you don't have like the one side. There's no one. And so you have to end up building a table that what we call it, I call it a connector table. They call it a junction table on Wikipedia. But we need a little table that allows us to break a many-to-many relationship into, in effect, two many-to-one relationships in a connector table. And so this is a connector table. So you could think of this as, you know, there are many links here, but we don't have a way to model the many over here to here. And so what you do is you basically say, oh, there's a lot of these things. There's many that go to the one, the many that go to the one, and then in here you sort of create that manyness that you want to create. So it's probably just as easy to look at a sample of this. So let's imagine a learning management system where you're taking a class, and there are some people that are teachers and some people that are students, and many students are members of many classes. A student can be part of many classes, and a class has many students in it. So you can't really find the one end. And so what we do is we make a table called membership. And in that table of membership, we actually often don't put a primary key in at all. We simply put in two foreign keys. And if we're going to put a uniqueness constraint, we put a combination of the two foreign keys as the uniqueness constraint. So we say there can be duplicate user IDs and duplicate course IDs, but there can only be, you know, user ID, course ID combinations. That has to be unique. So you can make unique be more than one column. And so if you imagine a course table and a user table, there's a user ID, the name and email, and the course has a title and an ID. And then we have this little table that just is the connector table that shows the points out. And so we can expand this membership. So let's take a look at how that works. So we're going to create some tables, and these are very classic tables because these are the one end of it. So these are the one end of it. So it has a primary key, a title, a logical key, email. There's a primary key for course, and then there's text. So we add this unique to kind of indicate that it's a logical key. We're not going to allow ourselves to put any duplicates in here. Now the connector database here is a table member, and it has two foreign keys, user ID and artist course ID. And you can even model some data here. So I'm going to model role, which is going to be 0 equals student and 1 equals instructor. And then I'm going to indicate that the primary key or uniqueness constraint is the combination of the user ID and a course ID. Now when we say the primary key, it both limits our ability to insert duplicates, but it also allows the database to optimize its scanning because it knows that that combination is always unique, and so it can organize its disk structure and storage structure to understand how to look things up more efficiently, knowing that once it's found a user ID, course ID combination, it doesn't have to look any farther because they're unique. And so all of these contracts that we add speed things up, save storage, and makes things more efficient, but in ways we don't always know exactly how they happened. And so let's go ahead and make these. Let's go ahead and make these guys. I think I will start with a new database. I'm going to call it LMS for Learning Management System. No, I don't really want to do that one. And so I'm going to not create the table. I'm going to do everything in SQL. And so let me see if it's in my cheat sheet. Nope, that's not in my cheat sheet. So I'll have to fix the cheat sheet again for you. By the time you see the cheat sheet, all these things will be in there. So I'm going to go in here and I'm going to grab Create Table User. Actually, I'm going to grab them all. Watch this. Grab them all. Highlight all these. Go over to SQLite Browser. Blast them all in. And then I'll put a semicolon at the end of each one of the statements. And I'm going to run them. So does it look good? Yep. So I got a course, I got membership, 2 foreign keys, and I got user. So that all looks good. Okay, so now we're going to have to insert some data in. And we're going to insert from the outside in. And so we're going to just put the name and email. The ID will be automatically assigned for the users. And we're going to do the same thing, and the ID and the courses will be automatically assigned. So let me just grab all this stuff. Go into SQL. That has the semicolons at the end already for me. Thank you very much. Now I'm going to run it. And if I take a look at my data, now I've got primary keys for the courses, and I've got primary keys for the users, and I've got nothing in the membership table. And I of course have to remember what these values are, because Jane is 1 and Ed is 2 and Sue is 3, right? And Python is 1, SQL is 2, is 3. And so when I go into membership, I've got 2 foreign keys here and a role, and they just have to be for the course person combination. And so it's a little tricky to figure all this stuff out. But again, these are just numbers, and if you look at these numbers, user ID, course ID, role, well, user ID 1 is in course 1, user ID is in course as the teacher, user ID 2 is in course 1 as the student, etc., etc., etc. So I'm making these connections by just putting these little numbers in, and once again, conveniently, I have all my semicolons perfectly in place. So I go to SQL, and then I run that, and then I take and I look at my membership data, and there it is. So 2 foreign keys and a bit of data modeled at the connection. That's the way we say that. The role is modeled at the connection. So now we build all this stuff up, we can write some queries that take a look at this. And so what we're going to do is we're going to look at who's in what course and what role are they, and we're going to sort this in a nice way. So let's just take a quick look at the code we're writing. We're going to do a select from 3 tables: the username, the member role, the course title. So in effect, we're not showing any of the foreign keys or the primary keys. We're going to go from the user table, join to the member table, join to the course table. This is pretty easy to write. You know there are 3 tables you want to go across. The on clause is also very easy to write, right? The on clause models each of these connections, where the member's user ID is equal to the user's ID, and where the member's course ID is equal to the course ID. So we're going to concatenate all 3 of these tables together, but we're going to only keep rows where it matters. Now that this role doesn't participate, but we're going to print that out. And we're going to order it by the course title first, and then the member role second, and the name third. And so let's run that. So we've reconnected it. So Ed's the teacher of the PHP class. Sue is the student in the PHP class. Jane is the teacher in the Python class. Ed's a student, and Sue are students in the Python class. Ed's the teacher in the SQL class, and Jane is the student in the SQL class. And so we have many people there are many students in many classes there, and so we have modeled that, but we model that with this sort of table. And if you look at a piece of software that I've written called Sugi, which is a standalone learning management system that's built with learning tools, you will see in anything we're in membership where we have a user table, we have a context which is also the course table, and then we have a membership table, and you look, here's these foreign keys. It's kind of like that's the many side, that's the one side, many to one, and so this is now in effect a many to many between these two, but then it's modeled as a series of many-to-one relationships. And you see this all the time in all kinds of things where membership or other kinds of things are necessary, many-to-one, or many-to-many. So, with all that, there's so much to learn. It's both easy and complex at the same time. It's easy when someone shows you how to do it, but at some point you will learn how to build database models and you realize, oh, it wasn't so bad. It takes a while to get used to them. This really just is a quick walk. But the bottom line is what we just did seems like it was, wow, that's nice. Do you really have to do that? And the answer is, if you're going to scale at all, you absolutely have to, because you simply can't read and write data sequentially. You can't read through, update one little piece of data in a file by reading all the way through and then writing a new copy of the file. That could take seconds. And in a system like an online system, you get 1/100th of a second to do something like that. And the databases make it so that happens in 1,000th of a second. So ultimately, you simply have to take advantage of this. You just can't, if you're going to modify data, you can read data from flat files, but even if you're going to read a lot of data, if it's big, it slows down terribly. So it might seem like there's a trade-off that you could debate whether this is worth it, but if you're going to deal with a lot of data, you've got no choice. It's really not as much a trade-off as you think. So this has been a quick romp through databases. We talked a little bit about indexes. There are constraints. We talked a little bit the not null stuff. We've talked about that. Uniqueness, that's a constraint. Another whole area is what's called transactions, and that's the locking of little areas, so you can read an area, then lock it, and then update it to make sure no one else reads it. And so they make sure they either get the version before you looked at it, or before you change it, or after you change it. And so that's how you make sure that you can't do things having to do with bank account balances and get yourself in trouble. So these are a lot of SQL. It's really fascinating. SQL is a fascinating thing to use and learn and performance tune and enjoy. So relational databases are cool. This gets us started. The big thing is don't allow replication vertically of string data. Pull that out into a separate table, establish a primary key, and then have foreign keys that point to that primary key. It is not just how much data you store. It's sort of a compression way, as a way of compressing data. You might think strings take no data, but they do. Numbers take a lot less data, and it's both how much data that's stored, but also how much data has to be scanned. And that way joins work. That's part of the magic of why Oracle is such a successful company. It's a bit of art form, and it's something that you can work your whole life and always get better at.